This is our system, our smart bioreactor, composed by a physical part, electronics, and an interface, a web user interface. Now let's open the bioreactor and see what is inside. From the outside we can just see the indicator's LED, while looking inside we can see the Raspberry, the Arduino, the breadboard, and the virtual chamber. Here, this is our cell culture chamber, so we have here our sensors. The sensors we are using are two DHT11, 1 and 2. These are sensors for humidity and temperature, and we collect the humidity and temperature and send it to the breadboard and then to the Arduino. The last sensor we use is a brightness sensor that is on this side and send it again that data to the breadboard and then to the Arduino. Talking about the two DHT11, they are digital sensors, so we use digital pins, and so we don't need any pre-processing for the data. They are ready to send it to the Raspberry. Well, on the other side, the brightness sensor is an analog sensor, so we use analog pins for the data, and we have to make some pre-processing for the data to make it usable for the Raspberry. So we have not a brightness measurement. We have to convert the tension in brightness. Well, on the Arduino we have a first pre-processing. Particularly, we just rescale the data to obtain a value, a usable value. For this we use also resistors. Now data are sent from Arduino to the Raspberry via MQTT. On the Raspberry we have our real post-processing for our data. We use some statistic operators for our data. In detail we calculate mean and variance for our temperature, our humidity, and our brightness. We calculate the gradient of temperature too, and it is so useful to know how the temperature is inside our bioreactor, if there are some different zones with different temperatures. And last things we do, we use these values of temperature, brightness, and humidity to calculate our vitality index. That is the most important data for us, is an index that explains the real situation of our cells, that summarize all the different parameters in just one parameter. It goes from 0 to 100. 100 is the best value we can have, of course. To realize this vitality index, we use a sort of fuzzy logic to combine the different possible situations of different free parameters. So in our post-processing is also present a threshold comparator that has to notify us if some parameter goes out of security bounds. So we have a threshold for for temperature, a threshold for humidity and brightness. We have in any case an upper threshold and a lower threshold. If the data goes out of the threshold, we can see the alert LED switch on. So these are our LEDs. We have 4 red LEDs for the alert. As we can see, the left temperature alert LED, the right temperature alert LED, the humidity alert LED, and the brightness alert LED. The brightness alert LED now is on because the light is so strong and too strong for our thresholds. Then we have 4 yellow LEDs that gives information when the users decide to activate the manual actuation using the FREEBOARD. So the left temperature manual actuation LED, the right temperature manual actuation LED, the humidity manual actuation LED, and the brightness manual actuation LED. The last 3 LEDs we can see are the vitality index LED. We have 3 levels of vitality index. The low level, just 1 LED switched on, the mid level with 2 LEDs switched on, and the high level, that is the top level, with 3 LEDs switched on. So now we can see that the brightness is too high. If I cover a little bit the sensor, she returns under the upper threshold. So, and as we can see, as a consequence, the vitality index increase and reach the top level. This is our THINGSPEAK. As we can see, we have just 2 channels. One for the raw data, and if we open, these are our fields. We have the left temperature field, the humidity field, the right temperature field, and the brightness field. Now we can see the last 60 datas, but if we want, we can zoom showing just the last data. And now we will try. So if I am interested to see one single data or to see the single different samples and each 15 seconds, we can zoom and see it. Now let's see the post-processing channel. Here we can see the post-processed data calculated by Raspberry. So we have the mean of the temperature, the mean of the humidity, and the mean of the brightness. Then we calculate variance too, so variance of temperature, variance of humidity, and variance of brightness. And we have the last two fields. One is for the temperature gradient, as we said before, and the last is for the vitality index. Due to the limit of THINGSPEAK, we have to send data to a single channel just each 15 seconds. So, and as the same problem occurs when we want to retrieve data from THINGSPEAK. So we have to access to a channel just each 15 seconds. This is our online user interface. On the first row we can see the real-time data, the left temperature, the right temperature, the humidity and the brightness. Then we have another section for the vitality index and another section for the manual actuation. We can decide to increase or decrease each parameter, and then the last button is to switch off the manual actuation. And here we can see the graphs of THINGSPEAK. We imported here with using HTML because the users use this interface, this freeboard, and not THINGSPEAK. Ideally, they have not to go on THINGSPEAK to see the graphs, but just on the freeboard. Now we can talk about the data transmission. This data and this are sent to Freeboard and from Freeboard to Raspberry via MQTT, while this is a sort of REST. In fact, we use a frame where is included the link of this graph on THINGSPEAK. To make our system smarter and more IoT oriented, we decided to use Telegram to realize a bot that allows us to communicate with our bioreactor everywhere we are. So let's search our bot. Okay, this is our bot. The first instruction start gives us some information about the bioreactor, the bot, and then here is the data set of instruction of query we can use to ask some parameters value to our bioreactor. For example, if we use /gtemp, the answer of the bot is the bot sends a message to the Raspberry, and the Raspberry instantaneous gives an instantaneous answer, giving us the last measured value of the parameter we asked for, and the link of the HTML of the relative THINGSPEAK graph, so we can zoom on it and control the history of data and select each data we want. We can do the same for other parameters, and we can ask for all the parameters in the same message using /go. The connection requires some seconds. We can ask for the vitality, for example. Okay, and this is how we can ask to the bioreactor some parameter. The other important aspect of this bot is that he can notify us if something goes out of security bound. Okay, now we can check the automatic message of Telegram. For example, if we modify the light manually, so we can, for example, overlight the sensor. Now just a few seconds. So this is the alert message saying that the brightness is too high, about 326, so out of bounds. And as the same, we can receive an alert message for the vitality when it goes too low. let's see a real complete demo of our system. So we can start looking for example, the Raspberry is going. No? Yes. Okay. So it's receiving data from the Arduino, and so from the sensor. As we can see, MQTT receiving data. Then, now, if I want to change some parameters, we can for the sensor and go to the freeboard to see it. So, for example, covering the light sensor, we have to see the corresponding variation on the freeboard. Okay, so the light is decreased, and as an immediate consequence, on Telegram we receive the relative notifies. So brightness is too low, might better to turn on the lights. So it works, and as consequence, another consequence of this lower light is the vitality index that has not the top value. We have to wait 15 seconds for the vitality index because it is calculated each 15 seconds. And so we can see on the freeboard that the value is not 100 but 66.67, and as consequence the eye glare is switched off. And on Telegram we just received the alert. Actual vitality is so low, I'm calculating value of 66.67 instead of 100. Take care of your bioreactor. Now let's check the manual actuation. Checking the box on the freeboard, we can activate the manual actuation, and we can see that the corresponding LED switch on. And then if we switch off the manual actuation, the LED turns off. As we can see now that all the parameters are in limits and the vitality index is at the top level of 100. Now if we try to increase the light, we can see that the value increases, and as immediate consequence the corresponding LED of alert turns on, and on Telegram arrives the message informing us that the brightness is too high. If we wait the 15 seconds we need to calculate the vitality index, we can see that the vitality index is decreased and now is at the value of 66.67. So we can see that just the medium indicator is on, and as a consequence we can see that the corresponding eye level of vitality index is switched off. And on Telegram the message arrives informing us that the vitality index is low. So take care of our bioreactor.